Good morning, everyone. So thank you to be there. So here it will be to speak about how to create a oligo house from scratch, from beginning. But first, what's mean from beginning? Because a lot of you already made oligo, some never. So who already made oligo here, for instance? Just to have idea. A lot? Everybody already made oligo? Only one person? Two? Oh, okay. So we really start from scratch. So. Okay, thank you. So as I was introduced, I already set up a few facilities here in the world. So in Japan also, and all these things. So in Japan it was in 2001. So at this time, I want to say the oligo business was a little boring. So it was almost all the same thing. We just made simple DNA oligo and nothing else. But now, as my colleague explained, there are a lot of modification, a lot of opportunity. And since 2-3 years, as you know, the pandemic has changed a lot of things. So a lot of people want to start a new facility because they saw there was a tsunami, and so the usual oligo supplier were not able to supply them. So they want to start a new production. So here, what I will speak about is oligo synthesis chemistry. So how to handle complex oligo using conjugations, because sometimes some modifications are not. They don't like to be injected in the production of the oligo. They are sensible for the pH, for instance, or they are not available on the market. So also the selection of the instrument, the synthesis reagent, consumable. I will speak also a little about the post-synthesis process, the other logistic consideration, and for sure also very important, the safety and the waste management. A few reminder concerning the chemistry. So, of course, you know very well the oligo. There is the ribose. So in the ribose, if you see there, if the R is H, it's a DNA. If OH, we speak about RNA. There is also now the 2' methyl, the 2' fluoro, and all these things. And we can speak also about the phosphodiester and the phosphorothioate. There are the 4 bases in DNA and RNA and all these things. The oligosynthesis cycle. This is quite simple but complex at the same time. This is really a nice thing because it's just a cycle. You start the process, it continues. So imagine you have the solid support. Here it's my hand, and there is some protective group, the DMT. So the first step is to make a detritylation, so to put out the dimethylcitretyl. So you put out the dimethylcitretyl, and so you have some active site. The second step will be to make the coupling and the activation. So you come with the second basis on your end, on the support. But unfortunately, in chemistry, the yield is never 100%. Sometimes could be, but never almost. So next step will be to cap what was not reacted. And when you do that, you arrive with a phosphate, trivalent, and so you have to make oxidation. And so you continue the cycle till your oligo is done. So there are different protective groups. So you have to protect the different position in the basis. The DT, there is no protection. But for the DG, for the standard and traditional way, we use a DG isobutyryl. For the DA, you use the benzoyl. For the DC, it's also the benzoyl. After I will explain you what is the difference, it will be more in terms of a cleavage and the protection. The first one, so the DG is with a DMF, the DA stay benzoyl, and the DC is AC. There is also the ultramide. So here we speak about the pack for the A, isopropyl pack for the DG, and still acetyl for the DC. So, as I explained, after the synthesis, there are 2 steps done at once. There is the cleavage. What is the cleavage? Is to remove the oligo strand from the support. So you cut the link in 3' between the oligo you just produced and the support, and also to make the deprotection to remove the protecting group from the oligo. So what is the process to use? It depends also for the modification on your oligo, the kind of chemistry you have used. It also depends maybe of the validated deprotection procedure you have in your facility. But usually you can use ammonium hydroxide around 30%, 28, 33%. We can do both cleavage and deprotection. Some people use the AMA, so it's a mixture 1:1 of this ammonium hydroxide with 40% methylamine. You have to keep in mind, but I will explain also later, that the methylamine in some country is considered as a dangerous reagent. So for the traditional process, we use the ammonium hydroxide. This is, if you remember, I show you the basis. So this is the DABZ, the DG isobutyryl, or the DCBZ. This is, if you eat the oligo, it will take several hours. Okay, you can think that it's long, but sometimes it's good to do longer, and it's safer. After, you can use also the fast one, the BZ for the A, DMF, and the AC. It could be a few hours at room temperature with the hydroxide, or a few minutes with AMA. I will speak after of some secondary reaction which may happen with the AMA. We speak about transamidation. That's why we have to use the acetyl protected C. And if you have an oligo with a 3' or 5' or internal amine, you can also have a secondary reaction. For the ultramide, the one I explained, you can use potassium carbonate at room temperature for 16 hours. Of course, this is for the DNA. When you speak about the RNA, you have also to deprotect the 2' position with a TEA, 3HF, DMSO, and sodium bicarbonate. To do that, this cleavage and deprotection, you can use an oven, a heating block. You are not obliged, because you can also work in room temperature, and you collect the oligo in the tube, and in the next step will be to make some evaporation of the liquid for the next step, for instance, for purification. I spoke the transamidation. So if you are using the AMA, so AMA, okay, it looks nice, it's faster, it's easier, that's good. But there is potential secondary reaction. So that's why it's mandatory to use the acetyl protected C, because during the deprotection of the oligonucleotide, the beta cyanoethyl of the phosphate backbone, the acrylonitrile generated can react on the C protecting group, creating an N-methyl C, and so it will give you a mixture of the targeted oligo and also a secondary component. This is what I explained also with the amino. If you use a 5' or 3' amino, you have also a problem with the acrylonitrile and the beta cyanoethyl, and the DMF, the protecting group, can do the same. So what you have to do, you have to wash your support with some amine like DEA or TBA, and you can do the process. My colleague already speak about the pore size. I just remind you, but because it's very important, because some people sometimes have some issue. It's not due to the chemistry, it's just due to the volume you have to make the oligo. If you don't use the good pore size, you will have some steric hindrance, and so your oligo cannot grow. That's very important. So the number give them there in terms of size of the oligo is just an idea of the size of the oligo you can do. You don't think that if you use a 1000 angstrom, if you have a 75 bases, after that it's die, or maybe it depends also, because a T will be smaller than a G, so if you have a lot of G, it will take more space. So it gives you some idea. And when you select your CPG, you have to take into account this pore size, but also the loading of your support. Because of course, if you take a higher pore size, but maybe the loading is lower, so it's a good balance between, you have to decide which one to use. But I always recommend to use a big pore size, like that your oligo will grow easily. So for oligo, usually 1000 angstrom or 2000 angstrom for the long oligo, 80 ml, 2000 angstrom is requested. And also, I forgot to say, when we speak about the the position and also the volume we have. But also if you have an oligo with a lot of G, you can have some T-trade of G. And so there you will start to have some issue when you will make the deprotection and all these things. So as you see, an oligo make the synthesis, the cycle, it's easy. It's just you push on the bottom of on the instrument. But after that, according to the sequence, you can meet some issue according to the sequence. So in the process, of course, there are some ancillary reagents. Necessary reagent. So you need acetonitrile, D-block, activator, oxidizer, Tape A, Tape B. So in the next slide, I will give you some idea of a composition of this reagent. Usually when you start and when you have a new instrument, I always advise to start with a DNA because it's the easiest oligo to make. Because if you do some more complex at the beginning, maybe the result will be not linked to the instrument, but maybe linked to the quality of the reagent or the complexity of your oligo. This is a list of reagents you can use for the D-block, activator, oxidizer, Tape A, Tape B. Acetonitrile also, there is only one acetonitrile, but it's also important to use the good quality. When I put recommended, it's also what I did use. Of course, you can use the alternative. By the past, when I started, it was the 3%. If I take the example of the D-block, it was the 3% TCA in dichloromethane. Now we use the DCA in dichloromethane. Why? Because there is less chlorinated waste, and so like that, it's better for the planet. But now we are more and more working even for the other reagent to try to eliminate the waste. Because this is something very common for the oligonucleotide. You produce a small quantity of oligo. Let's say if you start at 1 micromole scale, at the end you will have 1 milligram. And when you see all the reagent, all these liquid you are using are waste. You start with it, at the end it's a waste. So what about the bottle size? I just mentioned that when you start a new laboratory, you have just to keep in mind that the ancillary reagent you will use more is the acetonitrile and the D-block. Activator, oxidation, and taping will be a smaller quantity. So 2 or 4 liters, 2.5 liters bottle are good enough. It depends also of what you are planning to do. If you are using a synthesizer making 192 oligo and you make 5 micromole scale, maybe you will need to use 10-liter bottle or a 10-liter container, or to use 2 bottles linked together for your liquid for the acetonitrile, or maybe to use some tanker, because me in my previous position, we did use a tanker of 1,400 liters for the acetonitrile. So it depends also, you have to estimate in advance. We have some Excel sheet to define what will be the consumption of this reagent, and so like that you know which kind of reagent you will have to use, which volume, and which waste will be generated. This is always the open question, maybe more because I'm based in Europe. Is it GL38? Is it GL45? In US, it's quite easy. It's GL38. In Europe, it's normally GL45. This is for the neck of the bottle. I don't know here in your country, maybe it's GL38, 45, but I think it's an important point to be discussed with your salespeople when you will start the production, to see how will be set up your instrument. And it's very important you discuss also with your provider of reagent what they can provide you. Of course, they will be able to provide you the acetonitrile and all these things, but you have to check that they have the good bottle size and the good neck, because I saw that by the past, okay, people order the reagent, but they were not able to obtain this reagent with the good bottleneck. That's very important. It looks so simple, but you know, sometimes you can be completely blocked for, I want to say, sorry about the word, stupid things. One thing is very important. During the oligosynthesis, water is really you need to avoid the water at maximum during the synthesis of oligo. So one thing, we use gas for the synthesis. The gas are used for different reasons, to put pressure on the bottle and also to provide inert conditions for the chemistry. I recommend, and we recommend to use argon. Argon 99.9999%. You can also use nitrogen. It's also working for the oligo synthesis. If you do short oligo, honestly, you will not see really the difference between argon and nitrogen. But if you do long oligo, you will start to see a difference in terms of quality or yield of your oligo. For the short one, yes, no big difference if you make 20, 25 bases. But if you make oligo 70, 80 bases, you will see some difference. I just checked some number. If you have efficiency of your reaction, if you make a 20-mer and the efficiency of your reaction is 98.5, you will have an oligo 73.9%. If your efficiency of the cycle is 99.5, you will have an oligo 90.5%. So it's very important to see where you can win a few percent. But for a 20-mer, it's okay. But if you do a 50-mer, 98.5 average is 45.7% at the end. For if you have 99.5, is 77%. So you see 30% difference, just a little 1% difference during every cycle. Don't imagine, you can imagine what will be the difference if you do a 100-mer. So any percent you will win during the synthesis is really an advantage. Don't ask your purification to make a miracle. I think the most important step during the process is the synthesis. If you make a good synthesis, the next process, the next step will be piece of cake. Because sometimes people say, oh, synthesis not so important, anyway, I will clean it. Yes, you will clean it, but your yield will decrease and you will have some impurity, you don't know why, and which impurity. This is also my vision. When you make oligo for research or for diagnostic or for therapeutics, okay, you are targeting some purity. It's very important. But when you are going, for instance, in therapeutics, one thing is also very important. What are the impurities? This is something you have to keep in mind. When you do an oligo for research, you're not so care about the impurity. When you are doing therapeutics, okay, your oligo is 92%. But the question is, what are the 8%? Or what are the 5%? And what is this peak, and why I didn't see this peak before, and why now I see this peak? So that's why you have to put in place a very solid process, and to have all the time the same production and the same profile for your HPLC and for your purity. For diagnostic too, but for therapeutics, it's even more important. If you are not able to have enough dry atmosphere, you can use an inline drying column. So you just put that between your supply of gas and your instrument, so like that you will dry the gas, and so it will be maybe helpful. Because I think here the moisture is quite high, so maybe you can use it also. Another thing we recommend is to put some molecular traps, so in the amidite, in the activator, and the acetonitrile, also to decrease the moisture. And we can provide you this one. I mentioned about the conjugation. So, okay, you have the cycle, the 4th step, but some modifications are not available on the market as phosphoramidite, or even some modifications are sensitive to the process because you have acidic step, and so maybe there will be damage. So there are possibility to make conjugation. So I will only mention 2 here. You will have a conjugation between an amino on your oligo and an NHS ester. So what is NHS? It's the hydroxy 6-nidyl activated ester. So you will do your oligo with an amino in 3', in 5', or even internally. And after you can do a manual process to add the molecule you want, maybe a dye or something like that, on the oligo. It's very important to control your pH. You have to be alkaline pH around 8.9. If you are not in this pH, the reaction will not be so efficient. You have to keep in mind about three things. The pH, I already mentioned you. Another thing, you have to have all the salt to be in correct form for the oligonucleotide. So it's very important to exchange all the ammonia and all the other ions to be lithium or sodium ion. If not, it will not work because you will have competitive reaction. And the first thing, it's normal because if you do chemistry, it's always the same. You need to be sure that your NHS ester is soluble in your reaction mixture. If no, it will not work. Of course, it's chemistry, but when you start a new lab, it's maybe things you don't think about. Here we are speaking about people making a new laboratory. They don't know it. But sometimes, oh, why? I mix it with this. It's not working. Of course, there is no contact. And another possibility of conjugation, it's a thiol with a malimido. And you can have a very stable covalent linkage. So you see there is the thiol on the oligonucleotide, and you arrive with a malimide, and you obtain the final oligo you want. It's very rapid, very stable, but it's also pH dependent. If you are between 6.5 and 7.5 in terms of pH, it's very fast, and you will have a very good product. For instance, at the pH 7, you will have the targeted reaction will be 1,000 times faster than the parallel reaction. If you go in a pH above 7.5%, you will have a competition between the thiol with the malimido and the amine with the marido. And so you will obtain two reagents. So just think about that. There are other chemoselective method. In terms of a thiol, you can use dithiol, so pyridithiol, and you can follow the same process. There is also the click chemistry. You, of course, already hear about the click chemistry. What is? You have an alcene on the oligonucleotide, and you have an acid on the things you want to add, and you make the reaction between. The acid can be quite simple on the first one I show you, or it can be also a dibenzocyclooctene azide. Sorry, I say acid because I'm from France, from Belgium. What about the synthesizer? Okay, when you set up a laboratory, think about space. I know here it's not so easy, you don't have so many space, but it's very important to have enough space to be able to go on the left of the instrument, front of the instrument, on the right, but also on the bottom. If you have to make any maintenance, anything, it's very important to think about space. Because if no, you will have trouble one day. At the beginning it will be okay, but you cannot be as in a room and be like that around the sweetie case. No, you need space. So when you will set up, think about that, the space for your synthesizer, the space for your HPLC, your QC, like that you will work more smoothly. Here there are the different dimensions of the different instruments we are selling. I will give you more information about this instrument later. So we have different instruments. We sell the Mermaid 4, we sell the Mermaid 6, 12, Mermaid 48X, Mermaid 96E, 192X, and 192E. So as you may see, there are different capability or capacity in terms of production. With the Mermaid 4, it's not so difficult. Mermaid 4, the 4 means the number of oligo you can do. Same for the 6, same for the 12. But the big difference will be maybe in terms of the scale, the range of scale. With a Mermaid 4, you can do a scale from 50 nanomole till 5 micromole. This is already a nice scale. But for instance, with a Mermaid 6 or Mermaid 12, you will start also from a 50 nanomole, but with some option, you can go until 200 micromole scale. So imagine 6 oligo, 200 micromole scale. If you make one sequence, it's 1.2 millimole, just for this. One thing very important when you select an instrument, it's the number of amidite position. Imagine, when you are young, you want to buy a car only for 2 people. But if you know that in 2 years you will have a baby, this car will not work. It's better to take a family car. But here it's quite the same. If you know you will make oligo with a lot of modification, let's say DNA, 2'-O-methyl, LNA, I don't know, 2'-fluoro, but it's already 16 position. And so it's good to take enough position directly. It's sometimes possible, it's always to upgrade after, but it will be a cost. So I think it's good to do it. Some people, sometimes they use less position, they clean the line and they put another reagent. It will work in terms of chemistry, it will work. But when you will have an audit or something like that, how can you define or defend the fact that there is no contamination about the previous reagent? So it's better to have independent line, phosphoramidite line, and so like that you can do it directly. For some instruments there is trityl monitor, for some there is no. So when you do the cycle, the first step I explained, there is the detritylation. So you put out the DMT and there is some orange coloration. So with this orange coloration, you can see if your synthesis is moving smoothly and efficiently. This is a qualitative monitor, it's not a quantitative. I want to say I made thousand and thousand oligo. At the beginning, I was looking a lot this monitor and this trityl coloration. At the end, I just come from front of the instrument. I just check one step. Oh, is it correct? Is it orange? You know that you will have the feeling of this. So if you have a limited budget, I think it's better to take maybe a few more positions of phosphoramidite and maybe not take the trityl monitor. But if you have the budget, the trityl monitor can be helpful for you too. All the synthesizer, we can do DNA, RNA. This is not a problem. The only difference it will be the time of contact when you will add the different molecule. So you can do DNA, RNA, all these things. You can do long oligo, whatever the synthesizer, if you use the correct support. We only supply a CPG, because CPG is working well. If you do short oligo, polystyrene is very good. It's working well. I can say that. I used that in my previous life. But if you do long oligo, CPG is better than polystyrene. And also, one thing is important is to check which kind of impurity you create. If you have if you use CPG, the impurity will be short oligo. So it will be easier to clean after. If you use polystyrene, it will be longer oligo. And so after that, it will be maybe difficult to make the cleaning with the purification. One thing is important also, we have a worldwide service. So wherever you are, we can assist you, engineer can assist you remotely. If it's just a small issue, of course, people will not come every time. Just we have some programs, so people you can contact, they can come to solve your issue remotely. But we have also service maintenance, and they will come to make some annually calibration, things like that, or to come to fix your instrument if there is a big issue. Instruments are quite stable and robust. It's not so fragile. It's just a picture of one of the instruments. You will see there at the entry there are some picture of other instruments. So we can speak after if you want about your needs, what you want. I may understand that maybe some people will have more confidential questions. So sometimes you don't want to have the question in front of other people because we are all friends, but maybe there are also some petty competitor together, we never know. So we can have some more private meetings so to speak about your question. I will try to do my best to answer it. I think I will be able to answer a lot of the question, but if not, I will ask my team, people more clever than me, to answer it. Okay, you have the synthesizer. It's very important to have ventilation. So use a fume hood or a snorkel. This is not really for the synthesis. The synthesis will work well even if you don't have fume hood, it will work. It's more for your technician. You have also the different reagent, it will work. But for the technician, it's very important to have this fume hood. You can also have a working hood or things like that. And I give some average airflow for this, 500 to 850 cubic meter per hour. And for the snorkel, it's 180 to 500 cubic meter per hour. As post-synthesis, as I explained before, after the cleavage and deprotection, the oligo, it's common to dry down the oligo and evaporate the excess of liquid. This is very important, and this is common to do that. There are different possibilities to do it. You use an evaporator, you can use a lyophilizer, or a speed vac concentrator. We offer an evaporator, and you can see which one we have on the right table. You see there are a lot of lines, but this is also linked to the voltage. There is the 220 volt or the 115 volt according to the country you are. We can assist you with that. When you do the cleavage, you can use this kind of instrument. You just put your column on the top, you put the ammonium hydroxide, you leave enough time, you collect the oligo at the bottom, and after you will make the treatment according to the temperature and the time you will have to do. When the oligo is done, but of course it's important to make a quantification of the oligo. You can use another drop to do this quantification for the single strand of DNA or RNA. You can also use a spectrophotometer to know, extrapolate the number of ODs or the number of micrograms you have produced. In terms of quality, okay, there is no good or bad way to make the quality. It depends also what you want to obtain. You can do just desalting oligo, just by precipitation. You can use a cartridge. So you remember the DMT, what's happened on the cartridge, you put the oligo on the cartridge, the DMT will be linked on this cartridge, you clean, you wash everything, and at the end you cut the link between the DMT and your oligo, and you collect your oligo. This is one way. I did use a lot of cartridge. And after you have, of course, the HPLC. You can use the RP HPLC or the ion exchange HPLC. You can do both also. Some people do the both HPLC to target very high purity. But don't forget, more you clean, less you have. This is also very important. And for the very long oligo, there is still the page, the polyacrylamide gel electrophases. But this is more for development. You don't do that for large scale, of course. I like to speak about the safety, and again, the safety, because we are working with chemical reagent, so we have to be careful. This is acidic, this is basical, so of course you have to use the gloves, safety goggle, lab coat. This looks normal, but some people who never made chemistry or laboratories, they forgot it. So it's very important to keep that in mind. Also, another thing, you have to think about the fire code. You remember I spoke about the ancillary reagent. These ones are very flammable. So according to your country, you have to check how you have to keep it, where you have to keep it, and what is the maximum quantity of reagent you can keep it. This is linked to your country, maybe your state, your city. That's something you have to check by yourself when you build a new labs. Some local ordinance may restrict how much flammable liquid you can use. I cannot answer you, but it's important you check it. And you have also to check with the fire department in your area. The same for the waste management. Okay, don't forget we have chlorinated reagent in the waste, so you have to use waste resist to this kind of reagent. And the halogenated waste, and also the volume. If you make, let's say, a few oligo nanomole per day, your waste will be quite small in terms of volume. If you produce, let's say, around 200 milliliter, If you produce, let's say, 24/7, 100 non-oligo 5 micromole scale, you can directly arrive to a few 50 liters, 100 liters, and you have to think how to manage that. And you will have to check internally how to manage and how to keep this waste. The same for the reagent storage, where you have to stock it. And don't forget, there are some control substances. I already mentioned in the AMA, there is the methylamine, which is considered as a control substance by the DEA. In the cap A, there is the acetic anhydride. It also could be considered as a control substance. You will have to check it. You will have with your safety manager, or I don't know how you name it here, but you will have to manage that and to check it. This is just a summary. You have to well define your current, but I put highlight future needs in terms of laboratory setup. It's important to well define. It's better to spend a few hours or a few days before than to run, jump on something, and after you say, oh my goodness, it was not what I was looking for. It's very important. You can also ask us to see, to advise you. We can also speak with you. We can do it. We have a lot of experts here in Asia, but also we have colleagues in Europe, in US to assist you. You have to keep the buffer stock and critical raw material in the good place. Be in touch with us according to the reagent. We have around 8,000 different references in our catalog. Of course, it's not 8,000 different chemical reagents. There is also the packaging. But I think we are quite unique. LGC is quite unique because we sell the instrument, but we also sell the reagent and all these things. We are a one-stop supplier. And I think it's really a good thing to be a one-stop supplier because we can assist you with everything. Imagine you buy the instrument to us, you buy the reagent, it's working well, you are okay. If it's not working well, you will say, oh, it's coming from you. If you buy the reagents from somewhere and you buy the instruments from somewhere else, if there is an issue, sometimes there is pinpoint, the supplier of the instrument will say, oh, it's not due to us, it's due to your reagent supplier. And the reagent supplier, oh, it's not due to us, it's due to your instrument supplier. No, we can assist you with everything. I think really it's an advantage for that. Don't forget to use the appropriate support, the CPG, porosity. I think it's something sometimes people forgot, but this is the very important step. And don't forget that synthesis, for me, is really the critical part of the process. Any person you want will be a plus for the next step. Keep in mind to limit the water content. Use fresh reagent when possible. We spoke about ammonium hydroxide. It's very cheap reagent. Sometimes it's better to use it and maybe to use a new bottle because like that, it's very cheap. Other point for the ancillary reagent, it's better to open the bottle, put on the instrument, and not have a small bottle and think, oh, I will buy a big bottle and I will transfer in the small one. When you do that, water will come inside, the moisture will come inside. It's not good to do it. And define well your workflow. So it means, oh, okay, I will do first the stock management, synthesis. After the synthesis, the cleavage deprotection will be done there. This time, I will do the quantification this time, the purification. Have a clear workflow. Do well your process. You have to establish your ISO. It's you to define which kind of quality you want, which kind of quality system you want. It will not be the same if it's for research, if it's for diagnostic, or if it's for therapeutics. And put in place that's why you have to put in place the appropriate quality system and also have a QA manager if requested. We can assist you with all this step. I think we have a lot of expertise. As it was mentioned, from my side, I have around 25 years, but my colleagues are even more senior in the field, so we can assist you with all these things. And we are a team, a worldwide team. So it's not only Asia for Asia, no, we work all together.